Hi guys, this is a quick update on the Wear project. So this is going to be a final design for us. We didn't have time to make multiple revisions. As you can see here, this will be the enclosure. These are the two holders for Velcro, so there'll be straps that go through and secure onto a leg, an arm, shoulder, a bicep, wherever the EMG can be measured. And yeah, so this is the interesting part. So there'll be an HDMI plug, or mini HDMI rather, that comes out of here. Now, the system is designed to have about 16 electrodes, but instead of having 16 electrodes come out all over the place and sticking to a subject, the idea was to have one wire coming out. So it's small, it's modular, it can be easily plugged in and out. So we explored HDMI, and it turns out there are all the wires. HDMI has 19 wires, uh, or 19 pins rather, and all of them are usable. So ideally, an HDMI cable will stick out of here, and it will attach right onto the electrode sleeve, where there'll be another breakout board, which we already have in mind. And we've tested it; it works perfectly. All there's remaining is to put the system together. So this is the power switch, just a normal slide switch. This is a micro SD port to charge the device as well as program the onboard microcontroller. This is the micro, sorry, that was the micro USB slot. This is the micro SD. And the micro SD records EMG signals obviously at high speed. And these are three buttons here for three that represent three different modes: the SD mode, the Bluetooth mode, as well as just your serial mode or debug mode. Now, this is the beautiful part. This part right here is a touchscreen LCD. The reason I went with touchscreen LCD is at the time when I started the project, I didn't actually know how many buttons we would end up needing. So I thought it was easier to just generate buttons on the fly and use them instead of actual real buttons. Turned out pretty well. Finally, I realized I needed three modes or three push buttons. So that's the BLE, SD, and just serial debug mode. So that's the cool part. It's make it transparent. You can see our PCB sitting right inside. It's flush, and let me make the bezel transparent real quick. Yeah, perfect. So that's a whole PCB. It's a 4-layer PCB. It took me a while to design because I have no prior experience with 4-layer boards, and uh, and I had to write everything, hand out everything manually to get it just perfect. So that's the controller we chose, TNC 3.6, a USB development board, 32-bit 188 megahertz ARM Cortex. Those are the other two daughter boards. There's a Bluetooth and there's a 9 degrees of freedom orientation sensor. So it just comes out, ideally a lithium polymer battery would just sit there, it's rechargeable, flush, and will be secured by the PCB. And the whole thing would be secured to the enclosure by those four mounting holes that you can see right there, and those small jet out pillars. Yeah, that's the Wear project in a nutshell. So came along really well, all in all. I like to say that most of the mechanical design was done by mechanical engineering technologist Maninder Singh, who's on the team as well. And since we're doing all three of us the project ourselves, just uh, we have to do all the marketing as well as the concept art, for promotions. So we came with a digital render. So it looks nice. That's a Stuttgart courtyard. Inventor has this nice feature where you can actually put your item and then make a 3D render video or image to get some nice cool pictures. Thank you so much for watching.